In this video, we are going to see about bus and its operations. So what you see in this picture, it is the photo of a motherboard that you can see when you open your laptop. So the golden lines that you see here, these are called as the bus lines. So these golden lines are called as internal bus, which comes embedded along with your computer. And this ones which you see here, so these are external bus. So this you may see when you buy a hard disk or an SSD to connect with your system. So what is bus? So bus is basically used to transfer data between the processor and the I/O devices such as a memory device or an I/O device. So it acts as an interconnection network between the processor and the I/O devices. So next we'll move on to the I/O interface. So when you have an input device like your keyboard, there will be a input interface which connects it to the bus. So this interface will consist of these components: an address decoder, control circuits, data and control registers. So this will be the flow. So a processor wants to read the data from keyboard. So what it does, the processor places the address of keyboard in the address line. Second step, the keyboard will recognize the address using your address decoder, and it will start responding based on the control circuit input. And once it starts responding, it places the data into the data line. So this is the flow for I/O interface. And now we are learning about the bus. So we have certain bus operations. So bus protocol, the term protocol means a set of rules that is used to define or govern the operations of bus among multiple devices. So the bus is going to be shared between multiple devices. So how this is happening perfectly? So that is governed by using bus protocol. So in your bus protocol, we have control signals. So every participant in the bus operation will have a role, and also there are schemes for operating the bus. So the control signals in the bus are, it can be an input or output. So if it is an input, read has to be enabled. So, and for output, write has to be enabled. That is, when the read-write line is 1, which means read is enabled, and when it is 0, write will be enabled. And there are also control signals to specify the data size, that is how much data can be placed at the bus at a time. It can be a byte, a half word, or a word. Similarly, there are also timing signals which specifies when the devices can send or receive data. And roles include master role and slave roles. So generally all the I/O devices are considered as slaves, and the master is mostly processor, and there are also other devices such as DMA controller, which controls the I/O transfer without the involvement of processor. So generally it is processor, and the slaves are I/O devices. And the bus operation schemes, there are two types: synchronous and asynchronous. In this video, we will be seeing about the synchronous bus operation scheme. So in synchronous bus operation scheme, every data transfer is considered, or it operates based on a clock signal. Whereas in asynchronous, the data transfer is handled by using handshake signals. So this is the basic difference between synchronous and asynchronous. So to repeat, synchronous operation scheme involves clock signals for data transfer, whereas asynchronous scheme involves handshake signals for data transfer. So this is an ideal situation for a synchronous bus. So what happens is that the three phases, that is, the processor places an address at the starting of a clock cycle T0. So here we are addressing the processor as a master. So master is placing the address at the start of T0. After that, what happens is that at T1, so before T1 itself, the slave would have recognized the address. And at the start of T1, the slave is ready to place the data onto the data line. So at T1, the data is placed on the data line and the master starts reading the data from the data line. At the end of T2, your data transfer is complete and now the processor can start with the next operation. So this is an ideal situation. The data transfer starts at T0 and ends exactly at T2. And now coming to a more realistic situation. So it's not the case as in your previous case. Here we are seeing the things in two different perspectives. So this at the upper side is the perspective seen by the master, and the second at the lower side is the perspective seen by the slave about the three data lines, that is your address, command and data line. So what happens at T0, the master is placing the address and command in the respective lines. But then there will be a slight delay when the master is placing the address to the address line and it actually appears on the address line. So that is the basic propagation delay due to the circuits. So at T0, exactly the address is not there in the line. So we have a slight delay and we are denoting that time as TAM. So TAM denotes the delay from master to the address line. Similarly, after the address is placed in the address line, immediately the slave will not see the address. So the slave will take some time to see the address. So that we are denoting by TAS. That is the delay from the address line to the slave. That is TAS. Okay. So now the slave has seen the address and the slave gets ready to place the data at T1. Again, exactly at T1, the data will not be available on the data line. There is again a delay. So that is denoted as TDS. That is the delay from the slave to the data line. And now the data is placed and the master sees the data again at the time TDM. That is the delay between the data line to the master. Okay, now the data is available. The master has started reading the data and it will not exactly end at T2. It will take some more time to finish the data reading process. So these delays has to be considered when designing a bus. So again, there are few more problems here. How to decide the clock cycle? How long should be the clock cycle? And that should depend on the speed of the device. Again, another problem is that how do we recognize that there is if the slave is not responding to the command placed by the master? So to overcome these issues, there is another signal which is called a slave ready signal. So by using this signal, what happens is that we are able to even wait for multiple clock cycles. If the particular slave is not ready, the master can wait till the slave ready signals becomes available. So with this signal, the data transfer goes like this. An address is placed and the command is also placed and the master is waiting for the slave ready signal to be available. Once the slave ready signal is available, the master will start reading the data and after one clock cycle of reading the data, it will lower the signal, slave ready signal, and the master can start with the next operation. So in this, the data transfer is spanning across multiple cycles due to the presence of a slave ready signal. So this is with the synchronous bus. So to summarize, in synchronous bus, we have seen every operation depends on the clock cycle. So at every clock cycle, one operation takes place, starting with the ideal case. So in ideal case, we have placed the address at the first clock cycle. and the slave has recognized the address and it has placed the data in the second clock cycle, and at the end of the second clock cycle we are stopping it. But it is not an ideal, meaning in real time it is not possible to have the ideal case. So we have included some delays. So for every operation there will be a delay involved. So again, it is not possible to respond every time within a single clock cycle for the slave, or the slave may not be ready to transfer the data. So in such cases, we are having another slave ready signal. So the master will wait for the slave ready signal. Once the slave recognizes the address and it is ready to transfer the data, it will enable the slave ready signal, transfers the data, and it will wait for one clock signal. And after one clock signal, the master should read the data from the data line. So after one clock cycle, the slave ready signal will be disabled. So what if the slave ready signal is not enabled at all? Master keeps on waiting. So to avoid that, there will be a timeout option also. If the slave is not responding for a long time, then the master will give a timeout error and it will abort the operation. So that's all with synchronous bus. So we will see about asynchronous bus in the next video.